Okay, so today we'll be looking at the quotient rule for differentiating a function. Okay, so let's look at the following. So let y be a function, okay, of x, and it has two functions, okay, it's got u of x and v of x. The difference this time from the product rule, which you might have seen, is that this is now a quotient, okay? I've got u of x being divided by a function v of x, okay? So how would we differentiate a thing like this? So the rule is, okay, this rule here, so dy by dx, that would be v, a function v, multiplied by the differential of my u function, subtract my u function multiplied by my differential of the v function, dv by dx, and that would be divided by v squared. Okay, so that's what the function, that is what my rule is for when I want to differentiate something that looks like this here. Okay, I could use prime notation for this, and how that would look is the following. So dy by dx, that would equal v u prime minus u multiplied by v prime all over v squared. Okay, so the thing that is, well, the rule is different from the product rule. The main rule is that we have a subtraction on the top now. The product rule had a multiplication, but we also are dividing it by v squared. Okay, so let's look at a couple examples of this today to show you how this works. Okay, so the first example I'm going to look at is y is a function that is x squared divided by x cubed plus 1. Okay, so that's what I'm looking to differentiate. Now we couldn't do this from higher, this would be too difficult, so we need this new quotient rule to help us with this. So my u, that will be the function that was on the top of my fraction, okay, and the y, so that's going to be my x squared, and my v is going to be the denominator, which is x cubed plus 1. I need to differentiate both of these for my rule, so du by dx would be 2x, x squared is 2x, and if I differentiate v, that will give me 3x squared, so dv by dx equals 3x squared. So we'll start off by writing down the rule that we've just wrote down. So dy by dx is v du dx, subtract u dv by dx all over v squared. Okay, I'm now going to substitute in my functions that I've discovered into this formula here. Okay, so if I do that, okay, so v multiplied by du by dx, so that's going to be this v function here, x cubed plus 1 multiplied by 2x, so that's why I get 2x bracket x cubed plus 1. I then need to subtract u multiplied by dv by dx. Well, u was x squared multiplied by 3x squared, that's going to be 3x to the power 4 there. Okay, now remember, that's not my rule finished, my formula finished. I need to divide by v squared, so that's x cubed plus 1 all squared on the bottom there, so I get x cubed plus 1 squared. Okay, now again, that is my answer. However, it's always better to see if we can simplify our answer, so I can multiply out this numerator and tidy up. Okay, and if I do so, I get 2x to the power 4 plus 2x, subtract 3x to the power 4, still divide by x cubed plus 1 squared. And if I tidy this up, okay, I'm going to get negative x to the power 4 plus 2x. I can take a common factor of x out on the top. I am left with x bracket 2 minus x cubed all over x cubed plus 1 squared. Okay, so that would be my final answer for that question there. Okay, so that's one example of using this formula. You can see it's slightly different to the product rule. A lot of similarities though. We do need to continue doing our discovery of our functions here first, like we do when we use the product rule, but we're using a different formula, this one here, when we have a quotient. Okay, and we get our formula. So again, simplify as much as we can, as you might need to use it as a second part of a question. Right, we'll look at a second example. Okay, so again, I'm going to use prime notation for this one, just so that you can see both formulas in action. They are the same, it's just different notation. So I'm going to use the prime notation one. So I'm going to use vu prime minus uv prime over v squared. Okay, so my formula that my function I'm looking to differentiate in this question is y equals, and on the top, the numerator is sin x plus 2 divided by cos x plus 2. So my u is going to be sin x plus 2, the numerator, v is going to be cos x plus 2, which is the denominator. So in order to use the rule, I'm going to have to differentiate. So the differential of u is u prime. So u prime, okay, if I differentiate this, okay, the 2 disappears, so sin differentiates to cos x. differentiate v, okay, cos x plus 2. If I differentiate v, that's going to give me negative sine x. Okay, cos x differentiates to negative sine x. Okay, we should remember that from higher level. So using my formula, remember I need to divide by v squared, so it's vu prime minus uv prime over v squared. So I'm just going to substitute in my functions that I've discovered on the right hand side here into this formula here. Okay, so v multiplied by u prime, okay, so that's going to be cos x multiplied by cos x plus 2, so that's this function here. Then it's going to be take away u multiplied by v prime, so u with sin x plus 2 is going to multiply by negative sin x, okay. Now because we are taking away anyway, that negative will cancel with that take away, so that's why I get a positive here, that's plus sin x multiplied by sin x plus 2, okay. Remembering divide by v squared, v was cos x plus 2, so it's going to be cos x plus 2 all squared, okay. Moving on. Okay, that is our answer, but that is still nowhere near as nice as we'd like it to look. Let's see if we can tidy this up. So let's work on the numerator. If I multiply out my brackets, okay, I'm going to get cos squared plus 2 cos x. Multiply the second bracket, that's plus sine squared x plus 2 sine x. You might think that's us finished that point. However, using the rule that we have known, actually from National 5 level, that answer will become 1 plus 2 cos x plus sine x all over cos x plus 2 squared, since the rule cos squared plus sine squared equals 1. Okay, so that's why this cos squared plus sine squared, I've swapped with this 1 there. Okay, so there's two examples of how the quotient rule works. A lot of similarities to the product rule. Main differences, we do have a subtraction now as opposed to a plus for the product rule, and we also have to divide by v squared. So this is when we are wanting to differentiate something that is a quotient, okay, a function of x divided by a function of x on the bottom. Okay, thank you.